So here's our playground from May 25th to June 5th. I mean, we're going to be working on this idea and playing with it as much as we can. You can make this on paper very quickly. If you notice, I've got the Pentagon construction marks in here. So I made a circle. It's this kind of light colored circle here. Found a midpoint of that radius. Then I did that segment to the midpoint and I did the angle bisector. You see the construction marks for the angle bisector. That's in the chapter 1 of the book, angle bisector construction. Then I did a perpendicular. Let me show you how to do a nifty perpendicular. If you got one of these translucent rulers, you can get the line for, let's say, the 7-inch mark on the line that you want the perpendicular. And they line right up and you can make that perpendicular without having to do the construction for the perpendicular. It's like using a clear ruler as a t-square. So this perpendicular runs over here. Then you do that perpendicular like we did in the video. So you can see there's this pentagon marker there, but I didn't mark any of the other sides. I did do that perpendicular here for where the angle bisector hits the original diameter. So I've got marks for the pentagon and marked out the vertices that I got, because all I really care about is the vertices of the pentagon. Then I did the radii to each of those vertices. Then I did the bit where you take the compass and you put the point at a vertex, and then you adjust the size to hit one of the opposite vertices. Do you see? And then I drew that. But I didn't have to draw the whole circle like they do in Sketchpad. And once I've got this size, I just run around the circle and make these nice little arcs. Ba-doom, ba-doom, ba-doom. It's as easy as pie. I mean, I emphasized them with that red marker, but it was very quick to do. And drawing those radii, that's fast with your ruler. Then remember, you just have to get one time, Thanos, one time, extend two sides out like that. Once you've got that distance, then you can copy that distance from the center O out to there. You can copy that distance on appropriately drawn extensions of some of the segments that are already in there. So you don't have to extend all the sides, but what you do is you put the point of the compass there, extend it to one of the two vertices that go through a diagonal that skips one vertex. So you go up to there and you catch that point and that point. Yeah, it's going to be right. And then you draw that arc and you draw that arc. And that's all you have to draw. Now, the idea being, if you've done your reading and you're keeping up with us, this point F is antipodal to this point K, and this point P is antipodal to this point J. So if you're traveling along this segment and you hit P, you would reappear at J and come traveling along here. So in a sense, it's like having this triangle completed over here. And I guarantee you, this right here, 72 degrees. This right here, 72 degrees. This right here, 72 degrees, guaranteed. Now, what we're trying to do is model an icosahedron. An icosahedron has 20 sides. Each side is a triangle. Now, this is a Euclidean object, and the angles are all 60. But the viral capsid has a kind of a roundness to it. So we're capturing that roundness with this elliptic model where all the angles are 72, which you can't have in Euclidean. So, but this, you say to me, McDaniel, it's a 20-sided die. I only see how many faces here? 1, 2, 3, 4, 5. And then this is part of a triangle that's completed over here. This is part of a triangle that's completed over here. Well, then there's 5 here and 5 more triangles completed around the outside. That's only 10 triangles. You said we were modeling the 20-sided die. Well, we are, because all you have to do, if you want to see everybody all at once, is do this construction and then copy it flipped over. Or another way to see it is extend a lot of these lines, a lot of these circles, draw those arcs out. Anyway, I've got a nice finished picture of it that I'm going to attach to the email letting you know about this. we are going to be looking at questions like, what's the polar triangle of this triangle look like? And is it made of lines that we already know from this thing? What we're doing is we are exploring the elliptic geometry of a virus using pure math, just pure math. So stay tuned, be able to do this kind of thing, be able to make one of these, because then you can play on it. You can make this in paper and just be sitting out in the backyard, having a lemonade, listening to the birds, and you could be playing with ideas. And if you watch the wiki, you'll see I have plenty of questions to tackle. So this is our playground, this guy right there. Get good at it. Bye-bye.